Can they hear me?
I didn't know the latency's 36 seconds.
Ooh.
Really?
That's standard YouTube latency.
Okay.
2 viewers.
All right. Well, I'm sure we'll figure out if they can hear me or not soon enough in 30 seconds. So thanks for coming, guys, anyway, for those of you who are online and here. So today we'll be talking a little bit about LaTeX and how it works and basically just introduction. So it'll be useful for you throughout physics degrees and any other science degrees you might be doing, just for report writing and any professional papers which you might look into. So we're just going to do a very brief PowerPoint introduction, then we'll get onto some kind of practical examples on an actual LaTeX editor. But realistically, what we're doing is LaTeX here is it's another text editor. So it's a replacement for Word, which we're going to use here. So in general, instead of using Word and having all the nasty formatting errors, LaTeX allows you to have much more control over what you are doing and much more control over how everything is formatted, how things come together, how equations look, how figures look, and all the other various things which Word perhaps sometimes doesn't allow you to have so much control over. So LaTeX is also very script-based. So in Word, you have what we would call an integrated developer environment. And that's an environment in which you can go and you can use your mouse and you can click around everywhere and everything's kind of nice for you and you can insert things, drag and drop, things like that. In LaTeX, it's more like a programming language. So you write a series of lines of code and then it compiles your code into a PDF format, which is perhaps nicer in some ways. Okay. So that's what LaTeX is. Now, in general, LaTeX isn't like Word where you just have a LaTeX editor and then you can do everything in it like Word. LaTeX, you need to download things which you can then run in. So it's, again, you can think of it more like a programming language, but then you still need to download some editor which you can compile it in and run it in. So these are the two I would recommend. TeXworks is one which is you download it onto your computer and then it works. And then it will, basically as you download it, it'll talk you through everything. If you just search up TeXworks, it's pretty easy to go through. And it will download Text Studio and MikTeX and a few other things which you'll need. When you're also downloading it, it'll ask you to download a few packages. And don't worry too much about it. You can just select the basic ones. And if you require any extraneous packages, then it will go through when you try to compile and it will download them for you. So there's not too much stress there. Overleaf is a very popular web version. So TeXworks, you download onto your own computer. But Overleaf is one where you download it, you just run it in a web browser and then you can do your compiling and everything there. And all your files are stored online. So that's what we'll be using later today, just for people to kind of come over. All right, so with that said, we're going to look a little bit at Overleaf. So actually, I'll just here first show. So this is an example of what LaTeX can do for us. So this is one of the assignments which we had, report, and you can see here, this is the things that I write. And then it compiles into a document which looks more like this. So you can see here it has the abstract nicely formatted, and then it has your introduction, your sections. You can have figures, you can have equations here, such as here. It numbers all your equations for you. And then if we go down to the bottom, we have bibliography here, and then also appendix and various things like that. So it basically just formats it nicely as a bit more of a professional paper compared to what Word would do. Okay, so this to the side now. So if you guys want to, you can follow along using Overleaf. So Overleaf is, basically it's a similar thing to TeXworks, which is what I just showed you, but it's online. So here you can just go here, and if you just search up Overleaf in any browser, it'll just be the first one there, and you can just click on that, and that will bring you to where you need to be. And then just sign up with Google or something, and then it will store all your accounts along with your Google accounts. So on the left here, we have all of our projects. So we're just going to start a new project, for example. So here we can go new project, and we'll just do a blank one. And we'll just call this test. So if you do something like this, for example, then it should bring up a page like here, like so. And then from here, basically, it has various things which we will talk through in a second. So if you guys can just do that, I'll give you a little bit of time because there's a bit of latency. And then if you do that, then you can kind of come along with how we're going to go through this. Okay, so on the left here is everything we edit and we write, and then on the right is our compiled PDF document. So that's what it will look like at the very end once LaTeX has done its thing and gone through everything. So there's a few things we want to talk through here. So the first thing here is this document class. So at the top of every document, you'll have a document class. And this class basically tells LaTeX the general formatting of what it's going to be like. So an article is probably a very standard one. It's just you can do various editing in it. And then the one which we'll be using probably a lot is one which is called RevTech4. So RevTech4.1. So this was a document class which is written by Physics Review A. So Physics Review A is a very prominent journal. So if you're doing physics or anything, it's a journal basically where you would publish all the very high level papers in, and they've basically written this format for everything which is published inside their journals. So it's called RevTech4, and you can just do it like that. And then for example, also you can put things like 2-column beforehand, like so. Oops, sorry. And this will give you 2 columns of text instead of 1 column, as an example. But there is your document class. So you always start with that, and generally you'll either be using RevTech4 or you'll be using the standard article class. Okay, so that's the first one. Now, secondly, we have packages. So in general, this is just one package, but packages, if you can think of them, if you've ever done any programming languages, it's like importing libraries. So they're a library of things which have a series of commands which you can use in it just to make your life much easier when you're dealing with these various things. So an example of a very useful package, and one which you'll use a lot, is AMS Math. So this allows you to do various equations and things, and it imports a series of stuff so you can do nice things, such as it allows you to do equation arrays and things, which you wouldn't otherwise be able to do. But we'll go over that in a second as well. So there's various numbers of packages, but again, if you ever wonder why, if you need to do something, if you need a package for it, you can always just look it up and you can see what the package has, what it allows you to do. If you want to do a certain command, what package you need for it, all these things. And basically you just put all these packages at the top in your preamble, and then it just imports them and allows you to use everything in their libraries. Okay, now after the packages, we have here our title, and then the author here, and then the date. So you can see that these three is what actually starts appearing on our document. So our title, and then your author, the date. And again, I can put the date as today. So one thing I haven't mentioned yet, but all commands have basically a backslash in front. So you notice that all these are commands, and everything which doesn't have a backslash in front is just a standard, so this should be T column, is just a standard text. So something which you can just use before. So here if I do today, and if I was to recompile, I don't think it will work now because I've changed RevTech and a few things, but you would see that the date today would still stay the same. So it would still stay as March 2021, except it would also give the day. All right, so that's, let me just, okay, so that's the first thing. Now, after this, we have our begin document. So actually, generally, we'll probably put our begin document beforehand, before all this, but it doesn't really make a difference. It just tells us that the preamble's done and we're kind of starting writing most of our other things now. So after I've done begin document, I can actually start typing, and that will come up as text. All right, now also we have make title. So this basically just everything above make title is kind of compiled into a little bit of a title page. So it will compile everything into a title like this. So if I didn't have the make title, everything up here wouldn't appear on my page. So always make sure you put that in, and then after that you have sections, which is what we'll go through that. So if we just try compiling this. So, okay, so here we have errors here with how this is, but I think that's basically just on how, because I've used a different package. But I've made a previously I've made an example which I'm going to go through with you to kind of talk through everything here. So this is an example of a RevTech document. So again, so at the very top here, we have our document class, which is the 2 columns in RevTech. So you can see we have the 2 columns here, and that's based on what our document class at the top is defined to be. But that just gives an initial column. So later on, you'll see that we actually change down when we have the bibliography to just be a single column. So it just tells LaTeX how to start, but it's always, you can change it there. And then RevTech4 just allows us to use everything which the physics review people have kindly written for us. Now for packages, these are just standard packages I use. Again, there'll be templates. If you're in second year, they'll give you a standard template for it. Otherwise, this template and this document actually in general will be put up for you later on, along with the recording of this. So we'll put some things up so you guys will have access to this as well. But essentially, these first few packages allow us to do various things with mathematical symbols and mathematical prompts. Secondly, we have graphics. So we won't cover this today, but we'll cover this in a future workshop. And this is for figures, plots, anything you would like to put on, which is basically, copy and paste an image onto your idea. And then afterwards we have, allows us a little bit more column editing, but we won't worry about that too much. And then again, the rest is all quite simple and self-explanatory with the comments. Now here, the percentage sign tells us comments for each one. So everything which has a percent in front is basically just commenting in your source code, but you'll see none of it actually appears on my document on the right-hand side. All right, so everything up before this point, before line 19, everything here is just my preamble. So everything is, importing packages, doing my formatting, defining my document class, these sorts of things. But then after this, here's when we actually begin our document. And this is from this point on is where things will start to appear on our actual page. So firstly, here we have text height. So this is basically just your text size. You can set your font in some essence. And then again, if you ever want to do things on formatting, it's very simple to look things up for LaTeX commands. Again, title, so that's the title you see at the top here. The date, so here you can see the date is dated March 17th, 2021. And that's what the today command does for that. And then my author, which is myself, and then my affiliation, which could be Curtin University or your lab time and your supervisor, whatever is required for your particular presentation. Now after this, we have abstract. So the abstract is the bit which appears at the top here. So it's actually separate to the rest of how your introduction and the rest is formatted. And that's just how the physics review people like to tend to keep things. So they like to keep the abstract separately, so that's what we're going to do in this case. Now, if you put the abstract first here, then it goes up the top, and your abstract really should be, a few sentences as per your normal lab reports. Now, we have the make title after our abstract, and this essentially means that everything above this goes into our title page. That's why the abstract doesn't appear as two columns. So it's important that you put the make title after your abstract and not before it. As for introduction here, so now we have sections. So after we've made our title and everything, we're getting into the main body and the meat of the actual paper. So here we have sections, and sections are essentially titles. So every time I do a new section, it will make a new title here. So this one's titled Introduction, as I've put on the left. So it makes a section called Introduction, and that's the first section. And then you notice here I have the second section, which is Method, the third section, which is Results, fourth section is Discussion, and so on and so forth. So it will automatically, every time you put section, it will automatically give it a new numerical identifier. Okay, and then again, I can just type normally. So this is what I would just type normally, and then it formats it as I would here. So there's no special way that you need to actually type to put other text in. If you type without any commands, it will just put text in as you would normally do. So that's what a majority of the body of your text will be. Okay. Now we get to equations a little bit as well. So, actually, before we get to equations, so that's sections, and then we also have what we call subsections and subsections. So, if we go down to method here, so this is what appears as the method on the bottom. You can see here, after I've got method, I've given some amount of description of what the method will be, and then I've put a subsection here. So now the subsection will essentially come up as a subtitle of whatever section you're dealing with. So here, for example, it comes up as part A of the method section, and that's experiment 1. That's just the title I've placed there. And then I can put further subsections towards it. For example, if I wanted to say, okay, if I have an experiment and the experiment has a few parts to it, the first part could be on varying voltage, and then the second part could be on varying current, for example. And I can say, okay, subsection 1 is varying the voltage, and then subsection 2 is varying the current. So subsection 1 is voltage varying, and then under that I could have this set up to set up this particular part of the experiment, operations for it, and so on. So then the subsections are then numerically valued underneath that. So that just allows us to basically structure our document how we would like. But there's nothing more to how the sections and subsections and subsections work. Okay, so let's go back up now and talk a little bit about our equations. So here we have equations, and LaTeX will format all your equations nicely for you, but there are a few commands which we need to know. So f equals ma here, the equation which comes up like this, comes from these 3 lines of code here which I've highlighted. So the first line, begin equation, whenever you just have begin equation, it refers to a single line equation. So in this case, I can only have a single line, so I can only have f equals ma. I can't have something like I've done below, which has 3 lines or multiple lines. So begin equation is only for a single line. Now, the asterisk after the begin equation, after the equation here, tells LaTeX not to number. So you'll notice here that some of my equations, so f equals ma, has no numerical numbering system, but then afterwards I say, okay, I'm going to label this equation as 1, this equation as 2, and this equation as 3. So if I take this asterisk off and recompile, you'll notice here that those numbers will change. So the f equal ma will now have a number 1 next to it, and then everything will increase by 1. So basically the first time you number an equation in your document, you'll get the first number, and then every consequent one after that, you'll increase your number by 1. Okay, now, so we'll just leave those in. All right. Now we get to the multi-line equation. So if you just use begin equation and end equation, so you have to have the full block, then you just get a single line. If you want multiple lines, you have to use what we call equation array. And please notice you have to import the AMS math package for this to work. So equation array, so these lines here from 47 through to 51 are the lines which give f equals ma, which equals 5 times 10, which equals 500 newtons for this case. So you can see here that we have a series of lines of our equation, and they're actually nicely formatted so that all the equal signs lines up. So the first thing to note about that is that you have alignment. So the alignment here is this ampersand here. So these 2 ampersands tell LaTeX what to line up, so that on every line, whatever's in between my 2 ampersands will line up together. For example, if I change these ampersands and I put them in front of the f here, like so, then you'll see that it actually changes the alignment when it recompiles. So now these equal signs below line up with the f and not with the second equal sign here. And again, if I change that back to around the equal sign, oops, then when it recompiles, it'll format it nicely again, and all my equal signs will be lined up. So whatever is in between my 2 ampersands is what will line up on each line. Now, secondly, these 2 lines here at the end, these represent a new line. So they represent a line break, essentially. And it's necessary to put those line breaks after every single line in these instances. And just for your information, you can also use them in your standard text, but it's not really necessary. So those just make a new line, and that means that it notifies that I've gone from the first line to the second. Because we don't necessarily use equals to break every line. For example, I can actually put a second equals here on this second line. And when it recompiles, I can have 2 equals in a single line before it goes to a new line, as is mentioned here. So from this, it's not the equals which tells LaTeX to make a new line in your equation. You have to put the double backslash. All right. Okay, so let's get rid of that. All right. Now the next thing to note is we have this no number here, so the backslash no number. And this just means that LaTeX won't number this particular line. So again, if I take this off, it has a very similar effect to the asterisk when dealing with single equations. So now you can see that now the first line and the third line are both numbered because I don't have a no number there. But the second line isn't numbered because I have this no number here before my double backslash. So that's another important thing to note. And if I put that back again and recompile it, I'm just saving the document. So Control S will recompile, or also Control Enter will recompile. Okay, and then from this, we can see that we only have numbering now on the last element of this equation array and not the ones prior to this. Have we had any questions so far? No. Okay, good. All right. Now, the other thing I'll mention here is we have a math remove. So some of your lab supervisors will be a little bit picky about this, that units and things like that have to be not in italicized fonts. So anything inside a mathematical equation will be italicized and have a different font compared to what's in a standard text. And math remove will basically just remove that font and then just have it as a normal text. Okay, so that's where I wanted to get to with the equation array. So that's all for that. Oh, and one other thing I'll mention is if I put equation array asterisk, same as the equation one before, it will get rid of all my numbers for every single one. But if you want a numbering on just one of them, for example, the last one, unfortunately, you have to put no number on every single line, which is a bit awkward, but that's the best we can do. Okay, so let's put that back. We can also do other fancy stuff with equations in LaTeX, such as what we have here. So we have summations, for example. This is a small part of the Taylor, or this is the Taylor series of a various expansion function. And then here we can even write matrices and things like that. But we're not going to go through that today because that's a bit more advanced, but we'll have another session on more advanced topics and also making things look nice in LaTeX. So that's just something to note that is possible in LaTeX, which is very difficult in Word. Okay. Now I've talked about sections and subsections, but what I haven't talked about is numbering. So particularly in method sections, for example, you might want numbers like this. So this is, step 1, step 2, step 3, part A's, part B's, all things like this. And this is possible using the enumerate command in LaTeX. So enumerate, basically you begin the enumerate and then you end it here on line 102. And every time I do a \item, it puts the number. So if I do item and I say this is item 1, not item 2, and I recompile this, you'll see that after this one, I have item 1. And then once I've done the new line, then I've got part B. So the ways I've done part A's and part B's, like we have here, is just simply do a second enumerate statement inside the first. So you can just stack them as much as you want, and it will keep doing a new numerical enumeration sequence. So that's useful, but generally you'll only need the first one, if that even. A lot of the time people don't like numbering in physical reports. Okay, and then again, item here will give me my second item, and then item here will give me my third item. So every time I make an item, it will just add an extra number in numerical order. Okay, and that's all for the first bits here. And then again, results and discussion is just the same as the sections I had before. Now we get to bibliography. So at the end, you can just say begin bibliography instead of beginning a section. So the bibliography and the abstract are not just sections. They're actually different parts in the RevText formatting. So that's important to note here. So when we get to here, we begin the bibliography. And you notice here we have one column grid. So if you remember at the very top, when we defined that we were having a RevText document, we also specified it would be 2 columns. Here, we've specified that, okay, we don't want 2 columns anymore, and we're going to revert to a single column. And that's why here it's only 1 column. So we can still change the number of columns afterwards at our discretion. Now, and then after this, we'll talk about bibliography items in another session as well, and how all this works. And lastly, we have appendix. So the appendix, generally what we do is we make it on a new page. So you can just do \new page or clear page, and then again, 1 column grid will just revert to the 1 column instead of the 2 which we specified at the top. And then appendix, if you just put \appendix, the RevText document. So this is only if you're doing an article document class, most of this the formatting specifically won't work. So this is part of what the RevText document style has imported in. So here we just have appendix, and it basically just starts where our appendix is, and then we can say, okay, each appendix section. So now when I put sections and subsections, it does the sections as an appendix. So appendix A is my first section, appendix B is my second section, and then this would be my first subsection of appendix A, for example. So again, it's a very similar idea to the sections and subsections which we talked about previously. So I hope that's given you some amount of introduction to LaTeX anyway. So it's just kind of a small, brief introduction to kind of get you thinking the right way about what is LaTeX and how is LaTeX different to Word, but what does it do the same, what does it do better? So again, this was just a very basic kind of introduction. Hopefully you could follow some of it along, have a go at, using some packages, playing around with LaTeX, making equations yourself. We will make this document available to you guys at some time. And then we will have future sessions as well, which deal with slightly more advanced topics, such as figures, and we'll also deal with some other equations, making things look nice, formattings, blank space, things like that. So I hope you guys enjoyed it, and yeah, we'll see you guys at the next workshop. Are there any questions that people have had?
Well, Angus has asked, can you make your own custom packages?
Yes, but it's not quite so easy. Again, I think I wouldn't recommend it for someone learning LaTeX right now.
That is beyond the scope of these 4 or 5 tutorials.
Yes, in fact, I will not go over that
Also,
at all.
Shouldn't there be a space between the 500 and the N?
Yeah.
Again, you can put that in your formatting. Actually, equations don't recognize spaces, so
Yeah, so how would you put the space?
okay. So if you want to do spaces for your formatting, again, I'll go over this next week when we do nice formatting. But you can, if you put the colon as the operator, it will give a space there instead of, so \colon gives an extra space, and you can add spaces in your equations. But I'll go over all spacing and stuff next workshop, or maybe the one after, I'm not sure. Is that all? All right, if that's all, then I think we'll close down here.